Hi, and thanks for tuning in to the CBA Podcast, a place where we chat about our own recent achievements in the area of electronics, software and mechanical engineering, and more likely than not, give excuses for not having done anything at all. Hello, and welcome back to another podcast episode. I think it's been 4 months since the last episode aired, and at the start of all this, I made the foolish prediction, if I remember correctly, that it would be a weekly podcast. After that, I think it became bi-weekly. After that, probably monthly, and apparently now it's one per quarterly. So, but hey, it could be worse. Today's topics are a bit of a mixed bag, as usual, and let's start off with funny stuff. There was an electrolytic capacitor that blew up in my face. It was not connected to electricity in any way, but I was baking it too long with a soldering iron. It was connected to a big ground plane, so I had to apply some heat for some time, and was looking at it and it exploded. Now, there were solder splatters all over the PCB near the capacitor, so I guess I'm lucky that I didn't get solder splatters in my eye. So what have we learned? Don't bake electrolytics too long. Maybe don't look at them directly when desoldering them. Maybe wear protective glasses. Yeah, sounds like a good idea, and this will probably happen again, but hopefully not in my eye. Here's a little bit about electronic gadgets that I found or bought. Maybe it's interesting for you too. First is EMC probes, magnetic field probes. I got them a long time ago. I hardly ever use them. They've basically been collecting dust for a long time. They look like spoons, long spoons. It's basically a stick with a loop at the end. You can connect it to a spectrum analyzer, for example, and you can move the loop over a PCB while it's powered on to see where EMC noise comes from. That's the idea. But in the previous episode, I had a differential probe that didn't work correctly or behaved erratically around a certain frequency. So I used these EMC probes the other way around. So not to detect noise from a PCB, but to inject noise into a PCB. So instead of a spectrum analyzer, I connected them to a function generator. And when moving this magnetic field probe over the faulty differential probe PCB, I could basically see where it would pick up noise. So if you move it around this area on the PCB, it would the measurement signal coming out of the differential probe would behave erratically. So that was quite interesting to see. It's not going to fix anything, but it's quite nice to see. Quite a nice tool. Maybe I use it again if I remember that it exists. One electronic tool I bought more recently is the TTI Iprober, which is a handheld magnetic field probe. There's no display or anything, just a stick basically that you can hold against a track on a PCB while the PCB is running or clip onto a wire. And the other hand goes to an oscilloscope, or I guess to a spectrum analyzer, or even to a multimeter. There's a fairly decent bandwidth, 5 megahertz I think. And the thing is, you can use it to measure current in PCB tracks without disrupting the circuit, so it's quite easy. And if you have a PCB that's not too dense, it actually works quite well. It has a calibration feature, so and the resolution is quite nice. The noise is quite low, so I like it. It's quite expensive, but maybe it's interesting for you. For example, you can measure not just measure, but also see the magnetic field lines around, for example, a bar magnet. So what I did here, just for fun, I have a function generator with a FM modulation feature, and the function generator has a voltage input which modulates the frequency. So if you connect the voltage output of the Iprober to the function generator and you select a frequency that you can hear, and you make a little amplifier of some sort connecting to the function generator output, you can actually hear the magnetic field lines, the intensity of the magnetic field lines according to the frequency you hear. So that's quite nice. You can move the tip of the probe around a bar magnet or a circuit, and you can actually follow the magnetic field lines. So it's quite educational, I guess. Now, I think both Dave Jones of the EV blog and Mike Harrison of Mike's Electric Stuff on YouTube covered this thing already. So please, for more information, look there. And also hands-on stuff, or look at the manual. I'll put a link in the show notes. It's quite expensive, but maybe it's worth it for you. And the last little thing I bought was something I should have gotten a long time ago. It's a USB adapter, current and voltage measurement thing, and power too, I guess. One end plugs into your USB power source, for example a USB charger or a laptop. And into the other end you can plug a USB device which you want to measure. And the device has a little display and it gives you the voltage and the current being, well, the voltage on the USB bus and the current being pulled by the USB device under test, let's say that. It's quite inexpensive, I think €10 or something like that, and it's really, really easy. So it's not an electronic load, it just measures. You cannot control the load, but you have other devices for that, so maybe at some point I'll get that as well. Tip for you, maybe. And FYI, I know this is probably the most budget podcast ever made, but the last couple of sections I recorded, I think 20 or 30 times, and every time it gets a little bit shorter, a little bit more to the point. So I do think about what people want to hear, and what I try to keep it interesting. So I don't want to put people to sleep, especially in traffic. That's not the best idea. So anyway, if you have comments or ideas or something like that about the podcast itself, please let me know. The contact information is, as always, on the podcast.cba.si page. And here's something good that came out of the whole coronavirus isolation episode that we had recently, at least for me. An acquaintance of mine made a live stream about his hobbies. So it was, I think, a substitute for the Maker Faire that didn't go through, and his idea was to show what he was doing on a live stream on YouTube, and maybe other people could also make a live stream about what they did. And so you could have a virtual Maker Faire, something like that. It's quite a nice idea. I watched it, and this guy is pretty much into 3D printing. Now, this is not going to be a whole episode or a whole long story about 3D printing, because I don't know a whole lot about it, but I've been playing with the idea of getting a 3D printer for myself many times, and I finally decided not to do that. And I'm not going to go through all the differences between various 3D printing systems or methods or printing services, but that's exactly what I did. I chose a commercial, professional 3D printing service. You can send them your design as an STL file, a 3D file basically, and they send you the object back. And everything else is their responsibility, so the object matches your model and is of high quality. So that's what I selected. I tried, I think, 5 3D printing services, and I chose the best one, best in terms of money and quality and hassle. So to make a long story short, for me, I'm not going to print my own stuff. I'm going to send off my drawing, then receive my model, and that's it. I'm going to focus on what I want to focus on. It's quite personal, I think, so please do what you want to do, or what you find challenging, or what you find interesting, or what brings you joy. It's quite personal. It's not my, this is what I want to do. So there's that. While making the decision, I made a little checklist for myself for comparing between different 3D printing methods, and also 3D printing it yourself versus sending it off to a printing service. And I'm going through that quickly, because for me it was quite helpful. First of all, there's the initial cost in terms of time and money, so for example the printer cost. Then there's the per item cost, also in terms of time and money. So I must say the 3D printing services that I use are quite expensive, or not cheap anyway, because the quality is quite high. It's not something you can do at home for cheap, I guess. Then there's the hassle before and after the printing, for example getting the machine ready to print, or pre-processing, post-processing, getting your software together, something like that. Then there are restrictions following from the 3D printing method. Now, for example, PLA printing or various home 3D printing methods, your model is going to fight with gravity. So unless you add supports, removable supports to your model might collapse during printing. You probably know that, so there's a restriction right there. Then of course there's the quality, print quality. And finally, for me, I wrote down the post-processability. So for example, can I post-process with a Dremel tool or a file or a knife or a soldering iron my 3D printed model easily? That's important for me. I want to be able to drill a hole through it easily. Hopefully that helps you, and once again, I guess all this stuff is quite personal, and everyone should do what he or she likes best, I guess. And although it's been a long time since the last episode aired, there's only one thing I actually made, I think. That was a LED planet decoration. I'll put some pictures and also a link to a video of that in the show notes. It consists of a 3D printed sphere of about 5 centimeters diameter, and in the middle of that, like the rings of Saturn, is a transparent acrylic disc, and rings on the disc are engraved out. So what I did was design the sphere in the center so that you can mount a piece of LED strip into it, which shines onto the side of the acrylic disc from the inside. So on the engraved zones you see the LED light shining out, and that's quite a nice effect, I think. And also you can hang these things from the ceiling. Right now I only have one because I just wanted to test it, see if it looks nice, see if it works. But what I eventually want to do is like make a little planet universe, mini universe hanging from the ceiling, and display a very nice effect on that, if possible. One funny thing is there's absolutely no electronics inside. Inside one such planet thing is just an LED strip, and it is suspended from the ceiling by 3 wires. That's the idea. These smart LED strips have a serial protocol where you can stuff data into it and light comes out, basically, and that's what I want to do. So the electronics is completely somewhere else. The wires by which the thing is suspended carries the power and the data. And of course there is electronics inside each such thing because there's a smart LED strip, but what I meant was the controller somewhere else. And for this controller, a while ago, I think I discussed this in a previous episode, I made a small LED driver board containing a microcontroller, a driver and a microSD slot, and I think an LDO. Now, I made a new version of this because the previous one has some flaws and was too big. It could be smaller. This one is a little bit nicer. I'll put some picture of that in the show note. And also, I made a small video reflowing this thing in the vapor phase oven that I use. So maybe that's interesting for you if you want to see what it actually looks like. Because this vapor phase oven I have here is a little bit, is a budget model, let's say that, but it works quite well and has a transparent cover. So what I did was just put my phone camera on the top and just film the whole thing. It's just 1 minute. Maybe you find it interesting, you can take a look at that. To get back to the mechanics of the planet decoration a bit, in the center there's a 5 centimeter diameter sphere. To model that, I use something I never used before and it's quite handy. Now, usually when I make 2D drawings I use QCAD, which is an open source, AutoCAD-like tool. You can make vector graphics like AutoCAD, something like that. And for 3D stuff I use OpenAscot, which is a programmable modeler. You can describe your model using a programming language, functional programming language basically. This time, to go from a 2D cross-section drawn in QCAD to a 3D model, the OpenAscot offers something like rotational or linear extrusions, I think. So you can offer it a cross-section that you drew in DXF format, for example, and it can extrude it or linear extruded or rotational extruded. So I drew the cross-section of one such sphere and rotated it 360 degrees and there's your sphere. So that worked quite nice. Maybe that's a tip for you. I'll put some pictures of that in the show notes, how it works, what the 2D model looks like and what the 3D model looks like. So maybe it's interesting for you, because I didn't know it existed. Now a little bit about the software architecture, if it may be called that, of all the software that's involved in this light effect. Now on the hardware side, I'd like to have a microcontroller that does nothing else than take RGB data from a micro SD card and display it on LED strips. And that's it, all the time, nothing else. And next to that on a PC I would like to have some higher level language, for example a scripting language where you can design your light effects, program your light effects, and the output of running this script should be the same RGB file that should go on the SD card, read by the actual hardware. So have a very clear split in the form of an RGB file between the designing your light effect and displaying your light effect. And one of the added advantages of that is that you can not just display your light effect on the actual hardware, but also make a visual simulation of that. So you can take the RGB file generated by your light effect script and play it on your simulation instead of on the actual hardware. And for that I made a small visual simulation of one such planet. For that I use a Gyro 2D library. It's a C library where you can compose a drawing using rectangles and circles and ellipses and gradients and masks and clipping and so on. And it works quite well. So that was just a proof of concept, and we'll see how that goes. And I think you can make a visual effect for the whole light effect that you want. So now I have to clean it up a little bit and make it a bit nicer, and maybe wrap the Gyro 2D API into my own preferred set of primitives, because that's the way my brain likes to work, I think. This project is an example of it's like a vehicle for learning new stuff. So, for example, the 3D printing service and the Gyro library and the extrusion of 2D to 3D. It's like using the project as a vehicle for learning new stuff. I have to have a reason for learning new stuff. I don't know about you, but that's what works best for me, I think. So we'll see how this works out. I have a lot of work to do, and maybe you hear about it in the next episode. So that was all for now. For more information, links and previous episodes, visit podcast.cba.si. Stay tuned, thanks for listening, and goodbye. And talking of planets, back in a not so distant past we had a game called 2D Earth, and it was a very difficult game running on a Nintendo Entertainment System. And that game used a zapper. It's a pistol where you can shoot at the TV and hit targets on the TV. So the background of this game was Earth has been invaded by aliens, and the last combat fleet of Earth had to flee out into the solar system, eventually reaching Neptune, where there was a last stronghold of humans, I guess. And from there they had to fight their way back to the Earth, hence the name of the game. And each planet in between Neptune and the Earth was one level. So the first level was Uranus, so it would display in big letters on the screen to Uranus every time you start that level. And of course you can pronounce Uranus in a different way, putting the emphasis somewhere else. So every time the game started we laughed our asses off, basically, pun intended. So just FYI.